We are going to do area under the curve, applications of integrals. Definite integrals is the area under the curve. So first question is exercise 8.1. Find the area of the region bounded by the curve y square is equal to x. Y square is equal to x is right side parabola. So this is the parabola and the line x is equal to 1 and 4. X is equal to 1 and x is equal to 4. This is the figure of the question. This is passing through the origin, right? 4, 0, 0. This is y square is equal to x. This is the line x is equal to 1 and x is equal to 4. You have to find the area of the region bounded by the curve lines and the x-axis in the first quadrant. Means I just need this area. This shaded area, right? So that will be required area is equal to 1 to 4 y dx. So this is 1 to 4. Y from here is square root x. The square root x dx. Let me explain you this thing first. When we are finding the area along this, in the x-axis, limits are in the x-axis, then we will always take y dx because limits of x are from a to b side. But if we are integrating with respect to y, means the limits are on the y, then it will be a to b x d. Most questions we will do by this method, but few questions, 1 or 2 questions are there which are easy to attempt by this method. Means we will take the limits on the y-axis and integrate with respect to dy. So here if you see, it's the area falling on y-axis only, this area, right now. So required area is y dx 1 to 4. So if we integrate this, this will be x 3 by 2 upon 3 by 2 limits 1 to 4. So area is 2 by 3 out. Inside this is 4 raised to power 3 by 2 minus 1 raised to power 3 by 2. So 4 cube is 64. 64 square root is 8. So 2 by 3 into 8 minus 1. So that is 14 by 3 square units. Area is in square units. Clear? Second question is same. Now only the change is the limits are from 2 to 4 and y will be equal to p root x. For the second question, the y will be equal to root 3x, limits will be 2 to 4. So you have to integrate this 2 to 4, p root x dx. Same way. Clear? Next question. Question number 3. Now what does it say? It is the upside parabola. This is upside parabola, x square is equal to 4y. So, and limits are from y is equal to 2 to y is equal to 4 and y axis in the first quadrant. So here what are we going to do? we are going to take this upper side parabola, and now the lines are y is equal to 2, y is equal to 4. And this is again in the first quadrant, so area is this, right? Area is this, right? Huh? Limits 2 to 4. So here required area is 2 to 4 x dy. What is x over here? X square is equal to 4y. So x is equal to 2 root y. No? So 2 to 4, 2 root y dy. Same question, just the limit is changed, but here the how when to take dy, this is that type of question. When the limits are on y and in the along the y-axis, right? It is written in the y-axis in the first quadrant. Clear? Next question is question number 4. Find the area bounded by the ellipse. For ellipse, we have to take this. We have to take this. Now, this is of the type x square by 4 square plus y square by 3 square is equal to 1, means this point is 4, 0. This point is minus 4, 0. This point is 0, 3. This point is 0 minus 3. You know now ellipse form x square by a square plus y square by b square is equal to 1. Then this is a0 minus a0 over here, 0b and 0 minus b, right? So this is horizontal parabola, sorry, ellipse. Now total area is required. There is no restriction of the region bounded by over here. So what can you say over here? Required area is equal to. Now I am shading this. Why? Because if I find out this area, isn't this 4 are equal only? Because the curves are symmetrical, so what will you write? 4 times shaded area. What is the reason you are going to give over here? As curve is symmetrical about x-axis and y-axis. Right? Therefore, required area is 4 times shaded area. So this is 0, 0. So what can I write over here? 4 times 0 to 4. This 4 limit. I am taking along x-axis. So this 4, 0 to 4, y dx. Now, what will be y from here? That is x square by 16 is plus. Let us find out. The simplest way is this is 16, this is 9. And I need to find y square. So y square, if I transpose this side, it will be x square by 16. So 16 minus x square by 16. If I take the square root, so it will be this. So what are you getting? Y is equal to 3 by 4. 16 minus x square. So if you want to remember this, then it is always b by a square root a square minus x square. Instead of changing into this, by writing all this step, if you can remember, then from ellipse it is always b by a square minus x square. So if I take this, it will be 4, 0 to 4, 3 by 4, 16 minus x square dx. Now, if you remember, this is the formula for a square minus x square. So, this is 4 into 3 by 4. A square minus x square formula is x square by 2, a square minus x square plus a square by 2 sine inverse x by 2. This formula of integration, right now. So, using this, if I write, what is a? 4, na? So, this is x square by 2, sorry, x by 2, not x square by 2. X by 2, a square minus x square plus a square by 2 sine inverse x by 8. Limits 0 to 4. Right? X by 2, a square minus x square square root plus a square by 2 sine inverse x by 8. So this will get 8. This 4 and 4 is cancelled. So this is 3. Now if I put 4, 16 minus 16 will get 0 here. Here it will be 16 minus 16. And when I put this 0, then this will be 0. So upper limit and lower limit both will make this term 0. So what I'm left with? 8 sine inverse 4 by 4 minus 8 sine inverse 0. So that is 3. 8 sine inverse 1 is pi by 2. Sine inverse 0 is 0. So I am getting 12 pi. 12 pi square units. The answer. Clear? Next, this is vertical ellipse. So same you will do, but take it along x-axis only. So what will be your integration? 4 times 0 to 3, b by a. B is 3, a is 2, a square minus x square dx. Clear? Because, sorry, 0 to 2, not 3. Sorry. Because this is of this type ellipse now. Here it is 2, 0. Here it is 0, 3. I missed it. So this is 0 to 2. 4 times 0 to 2, 3 by 2. Because I just told you this is b by a square root a square minus x square. So that is your y dx. So integrating it, you will get the answer. Same way. Next question is, find the area of the region in the first quadrant enclosed by x-axis, the circle. Now this circle is there, x square plus y square is equal to 4. Means radius is 2. So this is 2, 0. This is minus 2, 0. This is 0, 2. This is 0, minus 2. Right? Now line is x is equal to root 3y. Means you have to take a line passing through the origin, right? Because there is no constant, so this is a line passing through the origin. Now you have to find the area in the first region enclosed by x-axis, means this area, right? Right now, we need this area. Now, this area is again, if we see, this area is again into two partitions. If we if you see from this point, this is under the line, and from this point, this is under the curve, right now? So these are two areas. One is for line and second is for the curve. So we are giving this as name y1 and this curve as y2. Now I need this point also, point of intersection. So just put the value of x. So we are or put the value of y. So y is equal to x by root 3, no? So put it over there. X square plus x square by 3 is equal to 4. So I am getting 3x square plus x square by 3 is equal to 4. So we are getting over here 4x square by 3 is equal to 4, or x square is equal to 3, or x is equal to plus minus root 3, right? So this point is giving me root 3, 0 over here, right? I don't need y, so let us find out x only. So what is your required area? That is 0 to root 3 y1 dx plus root 3 to 2 y2 dx. Now you understood why did I write over there? Y1 is under this line. This line is y1. Touching this line is giving me y1 and this curve is y2, right? So y1 is, if I take, what is y1? X 0 to root 3 x by root 3 dx plus root 3 to 2 y2 is 4 minus x square squared. 4 minus x square squared, right? So let us solve it. This is 1 by root 3 out. This is x square by 2, limit 0 to root 3. Plus, this is x by 2, a square minus x square plus a square by 2, sine inverse x by a. Limits are root 3 to 2. So this is 1 by root 3. Root 3 square is 3. So this is 3 by 2, right? Plus, if I put the limits over here, this 2 will make this 0. So I am upper limit is 0 plus 2 sine inverse. 2 by 2 is 1, na? So sine inverse. This is your upper limit. Now let us put lower limit. So this will be root 3 by 2, 4 minus 3, right? Put the value of x as root 3. So this is 4 minus 3 and this is root 3 by 2. Plus 2 sine inverse root 3 by 2, right? So this is root 3 by 2, as this root 3 will cancel this and root 3 will come over here. So this is root 3 plus by 2 plus 2 sine inverse 1. Sine inverse 1 is pi by 2. So this is pi by 2 minus. This is root 3 by 2 plus 2 sine inverse root 3 by 2 is at pi by 3, na? 60. So this. So if I open this, this is root 3 by 2 plus pi minus root 3 by 2 minus 2 pi by 3. Root 3 by 2, root 3 by 2 cancel. Pi minus 2 pi by 3 is pi by 3 square units. Clear? Next question. Again, this is a circle. So let us take a circle. Then one line over here. One line over here. This is x-axis and y-axis. Then it says there is a line x is equal to a by root. Right? Find the area of the smaller part. Now, how will you find out the smaller part? X is equal to a by root. Rationalize it. So you are getting root 2a by 2. What is root 2? 1.4, no? So you are getting 0.7. Means this value is 0.7. So isn't it 0.3? So which one is a smaller portion? Isn't it this portion? Clear? Smaller and both up and down. So you can just take twice area of the, you can just write twice of this now, as the curve is symmetrical about x-axis. So what you will write? Required area. This is a by root 2. So this is your small, I hope this is clear to you. What did we do? We did rationalization, then put the value of root, that is 1.4 a by 2. So 1.4 is divided by 2 gives you 0.7. So this side is 0.7. So smaller side is 0.3, which is this, right? So we are finding this area. So now required area is equal to twice shaded area. Shaded area is this only, this one. Shaded area, that is twice 0 to a, because radius of the circle is a. So this is a0, and this is a by root 2. Sorry, then not 0. Sorry. The twice of area a by root 2 to a y dx. Right now, from this point to this point, I need to find the area. This is a by root 2 to a. So that is twice a by root 2 to a. Y is a square minus x square dx. So let us solve it. This is equal to twice of a by root 2 to, let us put the value, write the formulas directly. 2 x by 2 a square minus x square plus a square by 2 sine inverse x by a. Because this is standard formula only, so we written all the values, upper limit. Now let us put the upper limit. 2 is common throughout, so let us cancel this 2. We are just left with x into, so x is a into a square minus a square, right? Plus a square by 2 sine inverse a by a. This is your upper limit. Minus lower limit is, not this already taken out, sorry. Lower limit is a by 2 root 2, because this 2 is already gone. A by root 2 a square minus a square by 2 plus a square sine inverse a by root 2a, right? So this is 0. This is a square sine inverse 1 minus, this is a by root 2. 2a square minus a square is a square. So a by root 2, right? Because this is totally under the square. 2a square minus a square is a by root 2 plus a square sine inverse 1 by root 2. This a and a cancels. So this is a square pi by 2, a square pi by 2 minus a square by 2 minus a square sine inverse 1 by root 2 is pi by 4. Pi by 4. So this is giving me a square common. Pi by 2 minus pi by 4 is pi by 4, no? 90 minus 45 minus a square by 2 square units. Okay. So next question is find the area between y square is equal to x, right side parabola, and x is equal to 4 is divided into equal parts by the line x is equal to a. Find the value of a. Now, this is this parabola. Then x is equal to 4 and x is equal to, this is your x is equal to 4, and this area is equally divided by this line x is equal to 2. Means this is your x is equal to a and this is your x is equal to 4. Now this area is equal to this area, right? Or can I say this upper area, because this is symmetrical about x-axis, na? This curve is symmetrical about x-axis, so can I say area 1 is equal to area 2, twice of area, or you can say twice of area 1 is equal to twice of area 2, or area 1 is equal to area 2. So from figure, it's clear that curve is symmetrical about x-axis. Therefore, twice of area 1 is equal to twice of area 2 given. So area 1 is equal to area 2, na? What is area 1? This is A0. This is 4, 0. So 0 to a y dx is equal to a to 4 y dx. Curve understand. Curve is same. So y is root x. So this is root x 0 to a is equal to a to 4 root x dx. So if I take x 3 by 2 upon 3 by 2, limit is from 0 to a is equal to x 3 by 2 upon 3 by 2, limit is from a to 4. So this is giving me 3 by 2, 3 by 2 cancel both the sides. So I am just getting a 3 by 2, our lower limit is 0 this side, is equal to 4 raised to power 3 by 2 minus a raised to power 3 by 2, right? If I bring a to this side, so this will give me twice of a raised to power 3 by 2 is equal to 4 cube is 64. This is 4 cube, its square root, na? So 4 cube, 4, 4, 4. 16 for the 64. 64 square root is 8. So a 3 by 2 is equal to 4. So a is equal to 4 raised to power 2 by 2 square units. Right? Next. Next question is ninth question. Find the area of the region bounded by the parabola x square is equal to y and y is equal to mod x. So x square is equal to y and y is equal to mod x. This is the equation. So again, if I take this only, so if we take this only. So this is this side of parabola, right? And y is equal to x means one line is this side and one line is this side. This is mod x. So y is equal to x over here and y is equal to minus x this side. And what is written over there? Yes, total area. So you need to find this area 1 plus area 2. So what will you write? As the curve is symmetrical about, as curve is symmetrical about y-axis, therefore required area is equal to area 1 plus area 2, or you can say twice of y dx, or sorry, twice of area 2. Now, we need to find the point also. So we have y x square is equal to y, and this side y is equal to x now. So x. So can I say x square is equal to x, or x square minus x is equal to 0, or x into x minus 1 is equal to 0. The point of intersection is 0 and 1. 0 is this, so this point is 1. So you are taking. Now if you see this area, if I take, isn't this area under the line y1, and then this curve y2. If I subtract this, if the area under the line is this, and I subtract this area, this is this, and y is equal to x in this side. So area under this curve is this area minus this area, right? So can I say y1 minus y2? Twice of y1 0 to 1. y1 minus y2 dx. Which is your y1? Line is your y1. This line is your y1, and this parabola is your y2. So that is twice of 0 to 1. Y is equal to x minus y2 is x square dx, which is equal to twice x square by 2 minus x3 by 3, limit is 0 to 1. So this is twice of 1 by 2 minus 1 by 2. So this is 2 into 3 minus 2 by 6. So this is 1 by 3 square units. Right? Question number 9 is done. So the next question is, question number 10. X square is equal to 4y. means upper line, upper parabola. Upper parabola and x is equal to 4y minus 2. So this is x square is equal to 4y. And now this line x is equal to 4y minus 2. So if you check, this is x minus 4y is equal to minus 1, right? So if I make y 0, x is equal to minus 2. So this line will cut at x is equal to minus 2, 0. And if I take x 0, then y is equal to 1 by 2. So this point is 1 by 2, 0, 1 by 2. So this line is like this. Now you need to find the point of intersection also. So can I write x minus 2 is equal to 4y? So x square is equal to x minus 2 now, because 4y, I'm equating these two things. So x square minus x plus 2 is equal to 0. So x square minus 2, x minus 2, x plus. Wait.